All right. Good afternoon. Uh, Today we are gonna talk about six-bar mechanism where you need to deal with two loops. After we cover this, I'm gonna go over some examples um, for some mechanism that we have not covered. After we cover those examples, we should be able to do displacement analysis for any mechanical linkage mechanism. So for the homework that I'm gonna post tomorrow, um, I'm gonna ask you to work on some mechanical mechanism to do displacement analysis. So make sure that you learn about the steps and our approach to do that, then you can work on those examples, on those problems. All right, we had this six-bar mechanism with 4 binary links and 2 ternary links. So if I want to draw it here, so first of all, we need to find digraph freedom. N for this guy is 1 digraph freedom because n equals to 6, f1 equals to 6. Then we form the vectors by assigning one vector for each link. So for this one, I put the arrow at this end for this link. For this one, I put the arrow here. For this guy, I put arrow right here, right there. For this, I put the arrow here, one arrow there, and one arrow right there. So the length of the links are A, B, C, D, E, F, G, and H. For this vector, I can measure or assign the angle at this end, at the starting point, with theta 2. Link 1, ground, link 2. Link 3, I should measure right here. Link 4. For link 4, I have this vector, so I should measure theta 4 at this end of the vector, starting from ground all the way to this vector representing theta 4. This is not a separate link, it's part of ternary link, so I shouldn't add another angle here to be measured. So I'm going to move to the next link, which is this guy. From this end, I measure theta 5, and for the last one, theta 6. This angle, or this angle, or this angle, since they are not changing, it's part of the rigid body, so you can measure that. I'm going to need this one, so I label this as alpha, so it's going to be constant. So when I'm writing the constant here, it's going to be A to H, A, B, C, D, E, F, G, and H, and the alpha. This angle also is constant. Variables are theta 2 to theta 6. Nouns would be constant plus one of the variables should be given because degree of freedom is 1. I assume theta 2 is null, theta 2 and is 1. So the unknown would be theta 3, theta 4, theta 5, and theta 6. 4 unknowns. So we have 4 unknowns. If I form one loop, the way that we did for previous mechanism, with one loop is gonna give me one vector loop equation. And one vector loop equation, it's gonna give me 2 equations. It's gonna provide 2 equations, one in x component, one in x direction or component. Another one is one in y component. So these 2 equations can solve for 2 unknowns. So 4 divided by 2, I need to have 2 loops. So 2 loops needed. For this one, you can form one loop here with theta 2, theta 3, and theta 4. The other one is going to be this one. Loop 1, loop 2. So loop 1 is a 4-bar mechanism. See, 1 link, 2 link, 3 links, and 4 links. Loop 2 also is a 4-bar mechanism. 1 link, 2 link, 3 links, and 4 links. So I can, yes.
What's alpha?
Alpha is the angle between C and E. These two vectors. It's a fixed, it's constant, it's not changing, so it's given as a constant. So for a first closed loop, you can, if this is O2 and the O4, O6, D and C. So for the first loop, if I ask you to write a vector loop equation, just look for a point with 2 arrows ending to that. Point P is that point. So you can write O to A plus AB. Stop here. Go through the other path. O to O4 plus O4B. Yes.
You said that the number of variables divided by 2. The number of variables we have is 5.
Sorry, unknowns. I should, thanks for making this. Unknowns, because one of the variables is given, I should change it for unknowns. Thanks for. So, first loop equation is going to look like this. On that equation, on that 4-bar mechanism, constants would be A, B, C, and D. Variables would be theta 2, theta 3, and theta 4. Nulls would be constant plus theta 2. So we start from the loop at which we are given with the value. So since theta 2 was given, I'm looking from first loop. You cannot start from second loop because theta 2 is given and theta 2 is for the first loop. We can have theta 3 and theta 4 as an unknown for this 4-bar mechanism. You can solve this 4-bar mechanism with the techniques that we learned in this course. So find theta 3 and theta 4 by 4-bar mechanics. So theta 3 and theta 4 are none now. So we move to the second loop. For the second loop, just look for a point with two arrows ending to that. Point C is going to be that point. Write the vector loop O4D plus DC, stop, O4 O6 plus O6 C. I'm talking about second vector loop equation. In this loop, the constant will be E, F, G, H, and this angle, alpha. What would be the variable theta 4? The angle, this angle is theta 4, so this one is unknown, this guy. Theta 5 is unknown, and theta 6 is unknown. Let me call it theta prime 4. The angle between link E and the ground. But theta prime 4 is theta 4 minus alpha. If you know the alpha, subtract from theta 4, you will get the value for theta prime 4. We, on the first loop, we solve for theta 4, so you know the value of that. So theta prime 4 is now. Now theta prime 4 is now. We solve for theta 5 and theta 6. Theta 5 and theta 6. We can find those values. Does it make sense? So as I said, we perform 4-bar analysis for a given value of the theta, and we have possible answers for theta and theta 4. In this, on the second 4-bar mechanism loop, then you want to write the equation. Theta prime 4 is going to be theta 4 minus alpha, which is given. Theta 4 coming from the first loop, alpha is constant. We can write this one. Sure. So let's do one class activity. For a 4-bar mechanism, we might have 2 modes. The maximum possible number of modes are 2. How many possible modes can you see for this mechanism? This is what 2 mechanism. Is that clear? I'm asking for how many possible modes can you see here? For a given theta 2, how many possible modes can I get? between B and D. Okay.
Yeah.
Why didn't we include the vector for that?
Yeah.
Because this is one link.
Oh, that's just one.
Yes, it's a terminal link. So I add this one. The reason that I add this is because I wanted to make a loop. So I don't need this one to make my loop. Alex. 32. Is not? Number 17. Andrew. What do you think? Let me, for 1 theta 2, how many theta 3 and theta 4 can I get? If I have a 4-bar mechanism, for 1 theta 2, how many possible solutions can I get for theta 3 and theta 4? 2, if you remember, when we solve for theta 4, we could find, we may get T1 and T2 as a quadratic, as the root of the quadratic equation. So 2 values for theta 4. For each T1, I can get 1 theta 3 here and 1 theta 3 for this one. So I'm going to get 2 modes. This set and this set. So 2 modes. Now, suppose you are done with this mode, with this loop, and you get this set of results. You go to the second loop. For this theta 4, for this theta 3 and theta 4, you may get another 2 modes for theta 5 and theta 6. So for this set of data, I may get 2 modes here. You should run for this set of data, you may get another 2 modes right here. So 1, 2, 3, 4. You can get up to 4. If we start with theta 2, we may get 2 modes. Theta 3, 1 representing the first mode for the angle of theta 3. Theta 4, 1 representing the first mode for theta 4. And second mode is going to be theta 3, 2, theta 4, 2. 2 representing the number of modes. For this set of data, we have this 4-bar mechanism. So we may get another 2 sets for theta 5 and theta 6. Theta 5, 1, theta 6, 1. Theta 5, 2 and theta 6, 2. For this set, we may get another set of theta 5 and theta 6. 5, 3, 6, 3, 5, 4, and 6, 4. When I want to present the results, it's going to be, for this theta 2, I can get this and this, one set. This one as the second mode. This is third set. And this one is going to be fourth set. Yes? So what was the problem about? We were given with theta 2, we are solving for theta 3, theta 4, theta 5, and theta 6. So the question is, how many possible modes or results can we get by doing the displacement analysis? So by working on the first 4-bar mechanism, which is this, we may get 2 modes. If theta 2 is given, we are solving for theta 3 and theta 4. True. This is the 4-bar mechanism. This is the 4-bar mechanism. For this theta 2, we are solving for theta 3 and theta 4. You remember this 4. So what we did, we derived the vector loop equation. We got this quadratic equation. This quadratic equation. So for this quadratic equation, we are solving for t. T can get 2 distinct asymptotes. And t was theta 4. Tangent of theta 4 divided by 2. You remember? T equals to tangent of theta 4 divided by 2. You may get 2 value for t, so you will get 2 value for theta 4. So 2 value for theta 4. For each theta 4, you can get 1 value for theta 3. Possible modes.
Okay, so it's like possible.
Yes. And since so this flowchart is just representing that. Any question on this? All right, let me go over a Stephenson inversion. In a Stephenson inversion, we still have 6 links and 6 joints, but 4 binary and 2 ternary. But they have been connected in different forms. All right, this is the mechanism that we have. Still 1, 2, 3, 4 binary. This is the ternary, and the ground is another ternary link. So I'm gonna form the vectors. For this one, I put the arrow right here. For this one, I put the arrow right here. For this guy, it's gonna be right here. For this link, I put the arrow in this direction, and for this one, I'm gonna have the arrow at point D. So the way that I form the vectors, I can label the angle. For link 2, I should measure angle of theta 2 at this point. For link 3, I have this, theta 3. For this guy, theta 4. I should measure theta 5 at point D. It's starting from the ground, goes all the way to this length, and theta 6. We have 6 links. All joints are rotational. one link is not moving, it's a ground, so I should have 5 angles, theta 2, theta 3, theta 4, theta 5, and theta 6. A, B. So if this is A, this is B, this is C, this is D, this is E. G, H, the distance between these two. F, between this joint, OA, OB, OB. This one is D, this one is F, E, and B. So this is how I label the links and the angles. Constant would be A through H. This angle also is given. OA and OB, the angle between the ground and this line is beta. We need that, we need it later, but it's kind of fixed because the location of these two is not changing, so beta is going to be fixed. For now I'm writing here, but later we will see why do we need this angle. The variable would be theta 2 to theta 6. None would be a constant plus theta 2 because the graph union is 1. The unknown would be theta 3, 4, 5, and 6. We need number of unknowns divided by 2. 4 divided by 2. I need 2 loops. The first loop should be the loop which has theta 2 on it. So I look at this 4-bar mechanism, OA, A, B, and OB. So I'm writing loop 1 as OA, A to B, B, OB, and OA. So this is the loop. Loop 2. The loop number 2 that I can look at it, you have two options. Either use this loop, OB, B, E, D, OD, and OB, or use this loop, OA, A to E, D, OD, and back to OA. So either loop, you can consider this as loop number 2, or you can consider this as loop 2. I will look at this one, but it's true that if you want to go through this way, you should get a, you can solve the problem. So I will go with the OA, A to E, E to D, D to OD, and OD to OA. Here I just have the loop 1, OA, A, B, OB, OA, loop 2, which is this guy, OA, A, E, B, OD, and OA, and loop 3 is going to be OB, B, B to E, D, OD, and back to OB.
How come the vectors aren't like actually adding almost normally they're adding O to A, adding the BA, AB. How come this one is not? They all just
I have not started the vector
oh,
loop
you just
equation. I just formed the loop. I'm not talking about the vector. I just want to show why we need the loop. What do I mean by loop 1? It's not anything, I mean just following the loop. So in loop 1, which is this, the variables would be theta 2, theta 3, theta 4. And loop 2, loop 2. Theta 2 is in this loop, theta 3 plus alpha is going to be in this loop, theta 5 and theta 6. And variables in loop 3 would be theta 4. We don't have any variable here, theta 5 and theta 6. So we should start with the loop 1 because it has theta 2 and it should be a four-bar mechanism because it's a type of mechanism that we know how to solve for that. So we start with loop 1. Yes.
Loop 2 is like a 5
Yes, but it doesn't. We will see how can we work on that five-bar mechanism.
Like the same equations you still have, like
Yes.
just from these.
Yeah. Yes.
How come for the watts we didn't do like a big loop?
We can do that.
You could? Like you
Yeah.
do one loop, two loop, and then the whole thing together?
Yes. But the way that I formed the loops, that one was easier to set it up. I mean, here I just wanted to show you have two options. Either loop 1 and 2 or loop 1 and 3. I'll go with these two. And 4. You can go with 1 and 2. So now it's time to start working with the first loop. The first loop equation, OAA, point P has two arrows ending to that. Write the vector loop for that. OAA, vector plus vector AB. Stop here. Start from point OA, go to the other way. OA, OB plus OB, B. This is the vector loop equation. Write the constants. Constants are A, B, C, and D, and that loop variables are theta 2, theta 3, and theta 4. Theta 2 is given. We are solving for theta 3 and theta 4. So we can get theta 3 and theta 4. Okay, and now I'm looking at second loop. First, I'm writing the vector loop equation for that. Loop 2. I'm done with loop 1. I'm looking at loop 2. Loop 2 is starting from OA. The point with two arrows into that is point E. So OA, vector OA plus AE, stop here, equals to OA, OD plus OD, D plus DE. This is the vector loop equation. Write the X component. Which would be, this term has A cosine of theta 2, AE has E cosine of, the angle of this vector with the ground is theta 3 plus alpha. So it's going to be E cosine of theta 3 plus alpha. Alpha is constant, theta 3 is coming from the first loop. OA, OD, the length of the vector is F, the angle of the vector from the ground is beta. So cosine of beta. This is where we need angle of beta. This is the angle of this link with the ground. It's not varying with time, so it's given, it's a constant. g cosine of theta 6 plus h cosine of theta 5. So y component change cosine term to sine. So I have two equations. The unknowns are theta 5 and theta 6. Two equation, one for x component, one for y component. Theta 5 and theta 6 would be the only unknowns there. I'm gonna get rid of theta 5 first. We can get rid of theta 6 first. So for the other one, back to this two equation and find that variable. So I'm gonna get rid of theta 5. If I want to eliminate theta 5, I should keep it in one side, move the other term to the other side. So I'm gonna keep h cosine of theta 5 in one side. This and this is gonna go to the other side. A cosine of theta 2 plus e cosine of theta 3 plus alpha minus f cosine of beta minus g cosine of beta 6. The rest is just math and trying to solve this system of equation. So you know how should be our approach. We are gonna square this, we are gonna square this both sides, add them up, theta 5 can be cancelled out. We eliminate theta 5, we solve for theta 6. But since I would like to simplify the notation, these three terms are now m, intermediate, and these three terms I note with the n. So it's gonna be n minus g cosine of theta 6. It's gonna be n minus g sine of theta 6. Just to simplify the notation. Theta 3 is coming from first loop.
Oh, okay. Hold on a second.
We are under step 2.
Yeah.
We are done with the step 1. So I'm gonna square both sides. Add them up. So if I square and add them up, I will get h square on the left side. I skip this side, I mean this step, so I'm just writing m squared plus n squared minus 2mg cosine of theta 6 minus 2mg sine of theta 6 plus g squared. So I'm gonna get, if I move to the other side, I'm getting m squared plus n squared minus h squared minus 2mg minus 2mg cosine of theta 6 minus 2 ng sine of theta equals to 0. It's similar to the 4-bar mechanism. We have theta 6, one for cosine, one for sine. So again, I'm gonna use another intermediate variable to simplify the notation. R for this negative 2mg p and negative 2mg as q. I'm gonna get p cosine of theta 6 plus q sine of theta 6 plus r equals to 0. On the 5-bar or 4-bar, we got something like this: P, Q, R. I mean, just the value of the P and Q and R might be different, but the equation would be the same. Again, T is gonna, because with a tangent half angle, T is gonna be tangent of theta 6 divided by 2. If we plug in T equals to tangent of theta 6 divided by 2, we end up to something like this, where R minus P T square plus 2Q times T plus R plus Q equals to 0, where this one is A, this one is B, this one is C. So AT square plus BT plus C equals to 0. We solve for T. Solve for T, you will find T1, you may get T1 and T2. T1 is gonna give you theta 6, because T is tangent of theta 6 divided by 2. If T1 is not, you can find theta 6. 1. This is gonna give me the second node for theta 6, theta 6 2. Back to this equation. I'm gonna solve for theta 5. If I divide both sides by h, I'm gonna get cosine of theta 5 would be m minus g cosine of theta 6 divided by h. And sine of theta 5 is gonna be n minus g sine of theta 6 divided by h. You have theta 6. Plug in here, you will find two values for theta 5. Plug in theta 6 here, you will find two values for theta 5 here. Find a matching pair, you will find theta 5 1. Plug in second mode here, get two answers on the first equation. Plug in theta 6 2 in this equation, you will get two angles here. Find the matching pair, theta 5 2. So you may get two modes over there. So we start with 1 theta 2, 1 theta 2. We looked at first loop, and the first loop I may get two modes, theta 3 1 and theta 4 1, theta 3 1, theta 4 1, and theta 3 2, theta 4 2. Working with this set, I may get two modes, theta 5 1, theta 6 1, theta 5 2, theta 6 2. I should check for this mode as well. I'm getting another two modes, theta 5 3, theta 6 3, and theta 5 4, theta 6 4. So one mode, two mode, three mode, and four mode. We may get four distinct modes. So on next week class, I'm gonna work on the different type of mechanism like this. We will start with the easy one, then we go to the more advanced or complicated multi-loop mechanism to see how we can work on this mechanism. This was one of the exam problems that I had 2 years ago. I asked the students to do displacement analysis. So we are gonna work on them on Monday class. No class tomorrow. Please go and attend to the carrier fair. It's not a great equipment for you. Pardon? Homework tomorrow afternoon by 5 p.m. You can drop on my mailbox. And the MATLAB file, I already created the Dropbox on the campus. No, it's my office is on E-Lab building, second floor. So you can find my mailbox on the second floor. E-Lab.
Okay.